we'll see some additional problems on Unit 1. So first is some rules of sum and product we'll see. First question is, Pizza Hut is currently serving 9 kinds of individual meals which are pizzas and 9 kinds of individual pastas. Bruce wants to try a different meal each day. So how long does it take him to try each meal once? So first 9 pizzas he can try in 9 days, and the remaining 9 pastas he can try in 9 days. So totally he can try 18 days with each meal a day which are not repeated. Second question, a boy lives at X and wants to go to school at Z. From his home X, he has to first reach Y and then from Y to Z. Then from Y to Z. He may go from X to Y either by 3 bus routes or 2 train routes. From there, he can either choose 4 bus routes or 5 train routes to reach Z. How many ways there are there to go from X to Z? From X to Y, he has 3 plus 2, which is 5 ways. And from Y to Z, he has 4 plus 5, which is 9 ways. And the total to reach from X to Z, he has 5 into 9, which is 45 ways. That is here, it is a product rule, and to get from X to Y, it is sum rule. Next question 3. There are 5 Chinese books, 7 English books, 10 French books. How many ways to choose 2 books from different languages? So this can be done is, what can be done here is from 5 Chinese books and 7 English books, he can choose in 5 into 7 ways, 1 book of each, and then or he can choose from 7 English books and 10 French books in 10 into 7 ways, or he can choose 1 book Chinese book and 1 from French book. So it is 5 into 10 ways. Totally there will be 155 ways. So next question, how many bit strings of length 7 are there? Here each bit can be either 0 or 1. So you have a string of length 7. So it is 2 into 2 into 2 7 times, which is nothing but 2 power 7, which is equal to 128. Next question, how many different car license plates can be made if each plate contains a sequence of 3 uppercase English letters followed by 3 digits? So these first 3 uppercase English letters can be selected in 26 into 26 into 26 ways, and the remaining 3 digits can be selected in 10 into 10 into 10 ways. That is, here the digits could be repeated. If the digits are not to be repeated, then it is 10 into 9 into 8. Next question. Suppose a variable names in a programming language can be either a single uppercase letter or an uppercase letter followed by a digit. Then find the number of possible variable names. So here, if it is the first is all uppercase letters, then it is a single uppercase letter, that is 26 ways, or an uppercase letter followed by a digit, that is 26 into digit can be selected in 10 ways. So it is 286. Next question. Each user on a computer system has a password which must be 6 to 8 characters long. So that means the length of the password could be either 6 or 7 or 8. Each character is an uppercase letter or digit. Each password must contain at least 1 digit. How many possible passwords are there? Now suppose I consider P is the total number of passwords, and let P6, P7, P8 represent the passwords of length 6, 7 and 8. Now by some rule, P is equal to P6, that is the string of length 6 or 7 or 8. Now P6 is nothing but it should contain all 6 characters must be either letter or a digit minus all 6 characters with only letters, which is nothing but all 6 characters with at least one digit. So that's why here it is 36. That is because you have 10 plus 26, that is 36, which are all, which contains all the digits and letters minus only the letters, which if you subtract you will get which contains at least one digit. So that's why your P6 is 36 raised to 6 minus 32, 26 raised to 6. Likewise, P7 is equal to 36 raised to 7 minus 26 raised to 7. And P8 is 36 raised to 8 minus 26 raised to 8. So P will be summation. I varies from 6 to 8. 36 raised to I minus 26 raised to I. Next question. A new company with 12 officers and 2 employees, Kate and Jack. How many ways to assign different officers to Kate and Jack? So the first person, it can be assigned with any of the 12 officers, and for the second person, because here there should be different officers, so it is 11 ways to assign for the second employee. So totally it is 12 into 11 different ways. Next question. Suppose either a CS faculty or a CS student must be chosen as a representative for a committee. In how many ways it can be done if there are 14 faculty and 15 students? Here it is by some rule, it is 50 plus 14, that is 64 ways are there to select one person. Suppose one CS faculty and one CS student must be chosen. It's for a committee. It is here, you can see it is and, here it is or. If it is and, it is product rule. If it is or, it is a sum rule. So here it is 15 to 14 different ways. Next question. A student can choose a senior project from one of the 3 lists. The first list contains 23 projects, second list has 15 projects, and third has 19 projects. Also, no project appears on more than one list. How many different projects can a student choose? So the first, from the 23, he can choose one, or from 15 he can choose one, or from 19 he can choose one. So it is 57 ways. So here the question is, one of the project from either of the list should be selected. Next question. A student can choose 2 non-overlapping projects from one of the 3 lists. The first list contains 23 projects, the same question, but here he can choose 2 non-overlapping projects, means 2 different groups. So then it is 23 into 15 or 15 into 19 or 19 into 23. Here he can choose 2 non-overlapping. Non-overlapping means they should be from different groups. So in these many ways. Next, a password must be 6 to 7 characters long. This is already done. So that's all from your sum and product rule. So in the next video we can see the problems on permutation. Thank you.